You've probably heard the term EVM frequently in the blockchain space. Originally built for Ethereum, the Ethereum Virtual Machine, EVM, is now utilized by various other projects such as Avalanche, Polygon, Binance Smart Chain, and Phantom. This highly specialized technology has become foundational for many blockchains. But what exactly is the EVM? What does it do? And how does it work? In this video, we'll explain the EVM, how it operates, and why it is so widely adopted across different blockchain platforms. First of all, let's talk about what is the EVM. The Ethereum Virtual Machine, EVM, is a decentralized computing environment that runs smart contracts and processes transactions on the Ethereum blockchain. It functions as a global cloud computer composed of thousands of nodes, individual computers, that work together to execute smart contracts. Essentially, the EVM acts as the runtime environment for smart contracts, enabling developers to create decentralized applications, dApps, using programming languages like Solidity. The EVM translates high-level code into bytecode, which is then executed by the network of nodes. This ensures that the same code produces the same results across all nodes, maintaining the blockchain's integrity and consistency. The EVM's ability to execute complex computations in a decentralized manner makes it a crucial component of Ethereum and other blockchains that have adopted EVM compatibility, allowing for greater interoperability and ease of migration for dApps. The EVM as a virtual machine. The Ethereum Virtual Machine, EVM, operates as a virtual machine, which is essentially a simulated computer environment running on the Ethereum network. Unlike a physical computer, the EVM is distributed across thousands of nodes worldwide, collectively contributing to its computational power. This decentralized nature ensures that the EVM is highly resilient and tamper-proof. In terms of functionality, the EVM mirrors the components of a traditional computer, such as CPU, memory, and storage. But it is specialized for executing smart contracts. Each node in the network runs an instance of the EVM, processing transactions and updating the blockchain state. The EVM reads and executes smart contract code written in high-level programming languages like Solidity, translating it into bytecode that it can process. This setup allows the EVM to maintain consistency and reliability across the network, ensuring that smart contracts run smoothly and predictably. Smart contract processing. Smart contract processing on the Ethereum Virtual Machine, EVM, involves several key steps. First, developers write smart contracts in high-level languages like Solidity, which are then compiled into bytecode, a low-level, machine-readable format. The bytecode is deployed onto the Ethereum blockchain, where it is stored in the EVM state. When a transaction interacts with a smart contract, the EVM retrieves the bytecode and executes it. This execution happens sequentially, meaning the EVM processes each operation one at a time to ensure accuracy and consistency. The results of these operations update the blockchain state, reflecting changes such as token transfers or contract state modifications. The EVM's consistent execution across all nodes guarantees that the outcomes of smart contract operations are uniform, maintaining the integrity and security of decentralized applications. Solidity and Bytecode Solidity is a high-level programming language specifically designed for writing smart contracts on the Ethereum blockchain. It allows developers to write code in a human-readable format, which is then compiled into bytecode. Bytecode is a low-level binary format that the Ethereum Virtual Machine EVM can execute. When developers write smart contracts in Solidity, the code must be compiled into bytecode using a compiler. This bytecode consists of sequences of instructions that the EVM interprets and processes. The compilation process transforms human-readable Solidity code into a form that can be efficiently executed by the EVM's distributed network of nodes. This conversion is essential for deploying and running smart contracts on Ethereum, as the EVM only understands and processes bytecode, ensuring that the same contract logic is executed consistently across all nodes in the network. Opcode and Gas Costs. Opcode is a low-level language used by the Ethereum Virtual Machine, EVM, to execute smart contracts. It consists of operational codes that represent specific instructions for the EVM, such as adding numbers or storing data. Each opcode corresponds to a particular operation and has a defined cost in gas. Gas is a measure of computational work required to perform operations on the Ethereum network. The cost of executing smart contracts is calculated based on the opcodes involved. More complex contracts with numerous or costly opcodes require more gas. Each opcode has a different gas cost, with simpler operations costing less and more complex ones costing more. This system ensures that resources are allocated efficiently and helps prevent network abuse by charging for computational resources used during contract execution. Cross-chain compatibility. Cross-chain compatibility refers to the ability of different blockchain networks to interact and work together seamlessly. The Ethereum Virtual Machine, EVM, facilitates this by providing a standardized environment for executing smart contracts. Many blockchains, including Avalanche, Polygon, and Binance Smart Chain, use EVM compatibility, allowing developers to deploy the same smart contracts across multiple platforms without significant modifications. This compatibility simplifies the migration of decentralized applications, dApps, and services from one blockchain to another, enhancing flexibility and reducing development costs. By leveraging the EVM, projects can benefit from Ethereum's robust ecosystem while taking advantage of other blockchains' unique features or lower transaction costs. This interoperability fosters a more connected and versatile blockchain landscape, enabling smoother transitions and broader adoption of blockchain technology. Now let's talk about the transaction processing in the EVM. Transaction processing in the Ethereum Virtual Machine, EVM, involves several key steps. When a transaction is submitted, it is first validated by nodes in the network. The EVM then processes the transaction by executing the smart contract code associated with it. This execution occurs sequentially, meaning each operation is performed one by one to ensure accuracy. The EVM updates the blockchain's state based on the results of the transaction. This could involve changes to account balances, contract states, or other data. Each transaction's execution alters the blockchain state, and these changes are recorded in a new block. The EVM's consistent processing ensures that all nodes agree on the state of the blockchain, maintaining the network's integrity and reliability. This process guarantees that smart contracts execute correctly and transaction outcomes are uniformly applied across the network. State changes in blockchain. State changes in the Ethereum Virtual Machine, EVM, refer to updates in the blockchain's data after a transaction is processed. Each transaction interacts with smart contracts, altering the blockchain's state, which includes account balances, contract storage, and other critical data. The EVM executes these transactions sequentially, ensuring that each operation is applied correctly. As transactions are processed, the EVM updates the state of the blockchain, which is stored in a series of blocks. Each block contains a record of the changes made during the transaction, creating a complete and immutable history of the blockchain. This mechanism allows the blockchain to maintain a consistent and accurate ledger of all transactions and state changes, ensuring that the network remains secure and reliable. In short, the Ethereum Virtual Machine, EVM, is a powerful and versatile component of the Ethereum blockchain, providing a standardized environment for executing smart contracts. It translates high-level Solidity code into bytecode that the EVM can process, utilizing opcodes to manage gas costs and computational work. The EVM's sequential transaction processing ensures accurate state updates and maintains the blockchain's integrity. Its cross-chain compatibility allows for easy migration and interoperability across various EVM-compatible blockchains. By understanding how the EVM operates and processes transactions, developers can effectively leverage its capabilities to build and deploy decentralized applications, contributing to a more connected and robust blockchain ecosystem. That's all for this video. We hope you have enjoyed this video a lot. How do you think the EVM will evolve in the future, and what potential do you see for its impact on blockchain technology? Drop your thoughts and predictions in the comments below. Don't forget to like, subscribe, and hit the notification bell to stay updated with our latest video. Thank you for watching our video. See you in the next video. See you in